Bismillahirrahmanirrahim. How are you, dear student? Hope you are fine and good. Okay, like in previous some lecture, we already discussed the circular motion, linear and tangential, linear or tangential speed or angular speed. So today we are going to solve some question of the linear and angular speed. Some problem or example solution. So let's see the first example. They ask the question here: did a car wheel turn 1800 revolution in 1 minute? Find the angular speed in radian per second. Okay, so we know that the angular speed formula, and we know that in one revolution, first of all we convert the 1800 revolution into degree format. Like we know that one revolution is equal to 360 degree. So in 1800 revolution, how many degree we have? So we will find, so multiply this part, so the degree will be equal to 360 multiplied by 1800 revolution multiplied by 360. So the answer will be, if we multiply these two parts, so this is equal to 648 this much degree. Okay, so we convert 1800 revolution to degree, so this is equal to this much. Okay, let's see again. You know that like usually in the angular speed they want unit in radian per second. Okay, we know that how we convert this degree into radian. Like radian formula is equal to pi divided by 180 degree multiplied by the given degree. So the given degree is this one, 648,000. Okay, so if we divide this one by 180, so the answer will be equal to if we divide this one by 180, so the answer is equal to 3600 pi. So this is radian. Okay, so now in the question they ask in 1 minute, like 1 minute is equal to 60 second. Okay, if we want to find the angular speed, omega is unknown, so just use the formula which is equal to omega is equal to putting this value 306 pi divided by how many second we have? 60 second. So if we divide 3600 by 60, so the answer will be equal to 60 pi radian per second. So this is the answer of this question. Okay, let's see the next one. Okay, next example they ask an iron wheel of radius 30 centimeter is rotating about in axis of the speed of 50 pi radian per second. Find the frequency and the time period of the wheel. The next one, the tangential speed at a point of 10 centimeter away from the axis of rotation. Okay, let's see here. First, convert the radius 30 centimeter is equal to 0.3 meter. Okay, next one, the speed is given, the angular speed is given, which is equal to 50 pi radian per second. This is already given. They ask the question that find frequency, time period is unknown. So in B part, this is in part A. In B part, we will find the tangential speed, which is equal to tangential speed we denoted by V, which is unknown. Okay, let's see. This is the B part, which is also unknown. If we want to find the time period, so we know that omega r angular speed is equal to 2 pi divided by time period, 2 pi radian into time period. Okay, so now putting the value, so the value of this one is also given, which is equal to 50 pi radian per second is equal to 2 pi radian. This is the formula, and time period is unknown. So just to find the time period, multiplied both sides by t. So now t will be equal to 2 pi radian. This is the formula part, and divide by 50 pi radian per second. So pi will be cancelled with this one, radian with radian. So 2 divided by 50 is equal to 0.04 second. So this is the time period. So if you want to find the frequency, we know that frequency is equal to 1 over time period. So 1, this means 0.04. The time period is already given. So this is equal to 25 hertz. This is the unit of frequency. Okay, the next part which is unknown, which is equal to tangential speed, the B part. So we know that the tangential speed formula is equal to 2 pi. There are some different formula, but I want to find directly like 2 pi r divided by t, or 2 pi r, if you can also use that one as well. So V is equal to, just putting the value, 2 multiplied by pi multiplied by the radius is 0.3 meter, and divided by the time period is 0.04, which is like we already found that one. So this is equal to, if we multiply 2 multiplied by 0.3 r, we can directly write, if we do the whole calculation. So this will be like 2 multiplied by 0.3 and divide 0.04. So this will be equal to 15 pi meter divided by second. So the tangential speed is equal to 15 pi meter into second. So this is the second part, which is what that they want the tangential speed. The next one, next one, let's see on the next page. Okay, this is your homework, dear student. Let's see the first example. In object moving in a circular path, try to solve this question with an angular speed of 0.377 radian per second. So what they want, an object moving in a circular path with an angular speed of the 3.77 radian per second. How long does it take the object to complete the revolution? Mean to find the time for this part. Okay, the next one, in this example there are 3 parts. Calculate the angular speed of the second hand of a clock. Like in the clock we have 3 different types of what hand. The first one is second, the second one is minute, the third one is for hour. So just find that these 3 parts, in the first one, second hand, find the angular speed for second hand, the second one is for minute, and the third one is for hour hand. You will find it's very simple. Just try and think about this. If you have some problem, then ask in your comments. A car driver round a circular track of radius this kilometer with a constant speed of 26 meter per second. What is the angular speed? You can also use, it's very simple. Simple formula is used for this one. So try to solve this question. If you have any kind of question, so you can ask. Inshallah, we will solve in the next video. Thank you so much for today's lecture.